Hello friends, myself Dr. Mitzi Patel, Associate Professor in Mechanical Engineering Department from Sulorok University. Today we discuss about the Introduction Chapter 1 from Basic Mechanical Engineering subject. So these are the outlines of today's discussion. First one is the prime mover, second one is types of prime mover, third one is force, mass and weight, then pressure, energy, specific heat, types of system, thermodynamic property and laws of the thermodynamic. So first we discuss about the prime mover. What is prime mover? So prime mover is the device, a simple device which converts the natural source of energy into mechanical work. So it is simple device which convert natural source of energy into mechanical work. In olden days, man was depend on the two things. First one is the physical strength, and second one is the animals like horse and camel. So prime mover are used the different source of energy like fuels, water, wind, and the solar energy. Now we classify the prime movers. So there are mainly two types of classification. First one thermal, second one is non-thermal. So thermal is also classified into certain types: fuels, nuclear, geothermal, biomass, or we can say that biogas, and solar energy. Non-thermal part is also subclassified into three types: water, tidal power and wind power. Now we discuss the fuel is again divided into two types. First one is the external combustion engine and internal combustion engine. External combustion engine short form is EC engine and internal combustion engine short form is IC engine. So what is difference between EC engine and IC engine? The combustion will take place outside the cylinder, that is called external combustion engine, and the combustion is take place inside the cylinder, that is called the internal combustion engine. In external combustion engine there are three types. First one is the steam engine, second one is the steam engine steam turbine, and third one is the closed cycle gas turbines. In IC engine, internal combustion engine is subdivided into two types. First one is reciprocating IC engine, second one is open cycle gas turbines. Now we discuss about the certain terms. First one is the force. Force is the product of mass into acceleration. Here you can see that the two figures. In one figure, boy is playing the football. In the second figure, two swings are there. Two different types of mass is sitting on the swing, and one person applies the same force on the two swing. So who has less mass is swing more, and who has high mass, more mass, is swing less. So the force is the multiplication or the product of mass into acceleration, that is called F is equal to m into A. So we can easily understand the concept of force from these two figures. Now we discuss the difference between mass and weight. So both the terms are very important. Mass is not depend on the gravitational force and the weight is depend on the gravitational force. So the weight of body is vary from moon to earth because the gravitational force is vary from moon to earth. Here in earth we have gravitational force value is 9.8 and the value of gravitational force on the moon is different. So the value of the weight is different. So the definition of mass, the mass of the body is defined as the amount of matter contained in it is called a mass. So the unit of mass is gram, or we can call it as a kilogram. Now we talk about the weight. So it is the force with which a body is attracted to the center of the earth, that is called the weight. So the weight is equal to mass into gravitational force. So W is equal to m into g is called the weight. Now we talk about the pressure, that is the very most important entity, or we can call it very most important properties. So the pressure is defined as force per unit area. How we define the pressure? The pressure is defined as force per unit area. So whatever force is applied or occur on the unit area, that is called the pressure. So pressure is equal to force upon area. P is equal to F by A. So what are the units of the pressure? The pressure unit are Newton per meter square, kilonewton per meter square, Pascal, bar. So these are the units of pressure. Now there are three pressure very most important for the subject is gauge pressure, atmospheric pressure and absolute pressure. So what is difference these three? If the pressure is measured by the gauge, any kind of pressure gauge is called the gauge pressure. Atmospheric pressure, the pressure exerted by the atmosphere on the body is called the atmospheric pressure. And absolute pressure, that is the actual pressure which exists in the system. So we can call as a absolute pressure is equal to gauge pressure plus atmospheric pressure. Now we move further. Next term is called a work. So how we define the work? So work is said to be done if body move along a direction of acting force. It means if I supply or if I apply the force on a body and that body is moving in the direction of applying force, that is called the work done by the particular body. So work is said to be done if body move along a direction of acting force. So the work done is given by the product of the magnitude of the force and distance traveled by the body. So if I wrote the equation, the work done is equal to force into distance traveled by the body. So W is equal to F into S. So what are the unit of the work done? First, Newton into meter, or we can call as a kilonewton into meter, or joule or kilojoule. So these are the certain units of the work done. Now we move further for the power term. So here you can see the one normal figure. Here one person is applying the force with 12 Newton on the object, and the distance traveled by that body in the direction of force is 5 meter. So in earlier slide we have discussed the work done concept. So here is the force applied is 12 Newton and the distance traveled in that direction is 5 meter. So 12 into 5 is equal to 60. The value of 60 Newton into meter is called as a work done in the direction of force. Here we discuss the power term. So the work done per unit time is called power. So power is equal to work done divided by, or we can call it the work done per time. So here if I have to find out the value of power, so 12 into 5 is the work done by the body into the time required is the 3 seconds. So 12 into 5 60, 60 divided by 3 is called the 20. So the value of power is 20. So what are the units of the power is Newton into meter per second, joule per second, kilonewton meter per second, kilojoule per second, watt or kilowatt. These are the unit of power. Now we move further the term energy. Energy, that means it is the capacity of doing work. It is a very simple definition. So there are two types of energy. First one is the high grade energy. Second one is the low grade energy. So what is the high grade energy and low grade energy? There are a simple term we can identify. Whatever energy we can supply to the system, that whole part of energy converted into the work done, that is called high grade energy, and certain amount of portion is converted into the work done, or we can call as a work, then that energy is called the low grade energy. So in high grade energy, energy that can be completely converted into work is called high grade energy, Let's take example is the potential energy, kinetic energy, and electrical energy. Now we talk about the low grade energy. So the energy of which only a certain portion of a can be converted into the work is called as the low grade energy. So the heat from the combustion of fuel, nuclear energy, these are the example of the low grade energy. Now we talk about the specific heat. So what is specific heat? So the simple definition of specific heat is the specific heat is amount of heat required per unit mass of a substance to raise the temperature by 1 degree Celsius. If I take one body, then that body's temperature is 20 degree. If I want to increase the temperature of that body is 20 to 21, so I need to supply the heat energy to that body. So whatever amount of heat is required to increase 1 degree Celsius temperature of that body from 20 degree to 21 degree is called the specific heat. So Q is equal to mc delta T, and C stands for specific heat. So we can make a subject. C is equal to Q by m into delta T. Q stands for heat transfer, C is equal to specific heat, m is equal to mass of substance, and delta T is equal to change in temperature. Now we move further the next point. These are the certain definition: melting point, boiling point, critical point, and triple melting point. So what are the difference between these 4 points? Melting, that means the convert the solid into the liquid form. So it is the point at which the solid gets converted into the liquid when heat is added. That is called the melting point. Now we talk about the boiling point. What is boiling point? Then the liquid form is get converted into the vapor form when we added the heat. So it is the point at which the liquid convert into the vapor when heat is added. Third one is the critical point. The critical point at which only one phase is present. Like if vapor is present, then only vapor. If solid is present, then only solid. If liquid is present, then only liquid. And we got talk about the triple point. It is the point at which all three phases are present. All three phases, that means the solid, liquid, and gas. All three phases are present. That is called triple point. So these 4 points are very most important: melting point, boiling point, critical point, and triple point. Now we discuss about the process and path. What is process and what is path? If I want to go from Ahmedabad to Vadodara, then whatever process I follow, that is called the process, and which path I follow for the reach Vadodara from Ahmedabad, that is called the path. If I follow the Vadodara Ahmedabad Vadodara Express Highway path, then that is called the path. So process, that means the any change from one equilibrium state to another of the system is called process. And path, that means the if the all the changes of state of system are plotted, like here you can see, I will show you the here you can see the state 1, that is called Ahmedabad, state 2, that is called Vadodara, and 1 2 3 4 5, these are the certain stages. So if all the changes of state of system are plotted and all the points are connected to the drawing the lines, these are the drawing the lines joining the change of state of the system is called the path. This is called the path. Now the we call as a cycle. Cycle is very most important term. Why cycle is my very most important term? Because here you can see the state 1 and state 2. Yes, we can consider the state 1 is called the Ahmedabad, state 2 is called the Vadodara. So if I choose from Ahmedabad to Vadodara via Tarapur Chowkಡಿ and return back from Vadodara to Ahmedabad via Vadodara Express, Ahmedabad Vadodara Express Highway. So the starting point and ending point, origin and end point is same then and then we can call as a cycle. So when a system goes through the different stage, or we can call it when a system goes through different change of states and return back to its original state, is called as a cycle, Now we will go further. Next topic, stress and strain. Here you can see there are the two figures. In one figure I apply the vertical force, and second one I apply the horizontal force. So there are the certain deformation occur in the vertical force and certain deformation occurs in the horizontal force. So what is the difference between these two deformation? That is called the stress. So stress is the force acting to a material divided by the material cross-sectional area, that is called the stress. So sigma is equal to F by A0. Sigma is equal to F by A0. So sigma is equal to stress, F is equal to force, and A0 stands for the original cross-sectional area. So what is strain? We already discussed about the stress. Now we will discuss about the strain. So strain is the deformation or the displacement of material that results from an applied stresses. Here I apply the stresses on two body. After apply that stress, whatever change in deformation, change in his body or shape, that is called the strain. Now we define the two important terms. First one is called the internal energy, second one is called the enthalpy. So what is the difference between two? So when I apply the certain amount of energy to the system, and that some amount of energy gets converted into the work done, and remaining amount of energy will be stored into the system, that stored energy is called as the internal energy. So internal energy is defined as the energy associated with the random disorder motion of molecules. So when the system is supplied with the heat, some amount of heat is converted into work, and remaining heat stored in the system causes rise in the temperature. So the internal energy is stored from of energy, that store from energy is called the internal energy. Q is equal to W plus U. U stands for the internal energy. So what is the unit of the internal energy? It's in energy. So joule, kilojoule, these are the unit of the energy. Now we discuss second term is called the enthalpy. So the enthalpy is defined as a sum of internal energy and the product of pressure and volume. H is equal to U plus PV. So the unit of enthalpy is kilojoule per kg. Now we define the three different terms. First one is the system, second one is a surrounding, and third one is a boundary. Here you can see that this part where the work is done, that is called the system. That outer part of that system is called the boundary, and the outside of the boundary is called the surrounding. Let's take an example. If faculties teach the student inside the four walls, then it's called the system. That four wall is called the boundary, and outside that four walls of the class is called the surrounding. So a system is a region containing matter chosen for investigating the changes in property due to exchange of energy in the form of heat and work, that is called as a system. So the example is boiler, turbine, refrigerator, solar cooker. These are the certain example of system. Now we talk about the surrounding. So everything external to the system is called the surrounding. And what is the boundary? So boundary is the closed surface surrounding a system through which energy may enter or leave the system. Boundary is separated the system and from its surrounding. Now We discuss about the types of system. There are three types of system. First one is the open system, second one is the closed system, third one is the isolated system. So first we discuss about the open system. See, in open system there are two terms. One is the mass, second one is the energy. So if mass and energy cross the boundary, then that particular system is called as an open system. Again I repeat, there are two terms. First one is the mass, second one is the energy. If mass and energy both are cross the boundary, then we can call as a system is open, or we can call certain example open container of boiling water or open cup of coffee. These are the example of the open system. Energy as well as the mass cross the boundary. Now closed system. What are the closed system? There are two terms. One is mass, second one is energy. Mass does not cross the boundary, but the energy can cross the boundary. Then the system is called as a closed system. So we take the example, the closed container of boiling water. If we close the container, then the energy can transfer, but the mass cannot be transferred. So that is called the closed system. Or cup of coffee with a lid on it, so that the energy can transfer, but there is no transfer between mass from system to surrounding. And in the last one, isolated system. What is isolated system? I nor mass and energy. There are two terms, mass and energy. Neither mass nor energy can cross the boundary. That is, then the system is called the isolated system. Again I repeat the definition. Isolated system, neither mass nor energy can cross the boundary, is called the isolated system. So we can take the example of the isolated system is thermoflux, but actually in the reality, practically, no, we cannot find any kind of perfectly isolated system. So the perfectly isolated system in practically does not exist. Now we talk about the thermodynamic properties. There are two types of thermodynamic property. First one is extensive property, second one is intensive property. So what is the difference between two, extensive and intensive? So in extensive property, the property which is depend on the mass of the system, that is called the extensive property. What is intensive property? The property which do not depend on the mass, or we can called as a independent of the mass. So the property which depend upon the size of mass is called as a extensive property. We can call as a mass, volume, enthalpy, energy. These are the extensive property. And we talk about the intensive property, the property which do not depend upon the mass is called as a intensive property. Let's take one example of the pressure, temperature, viscosity and density. These are the intensive properties. Okay, so these are the difference between extensive property and intensive property. Extensive properties depend on the mass and intensive property does not depend on the mass. Now we learn about the three main laws of the thermodynamics. First one is called the zeroth law of thermodynamics. Second one is called the first law of thermodynamics. And third one is called the second law of thermodynamics. I will give you 5 to 10 seconds. Just visualize this A, B and C figure. What are the changes in the color occur? Then we can go for the official statement of the zeroth law of thermodynamics. Just give, I will give you the 5 seconds, 5 to 10 seconds. Just visualize it. The change in color you can visualize. The color will be same after 2 to 3 seconds. You can see. After 2 to 3 or 3 to 4 seconds, the color will be same. So what is the statement of the zeroth law of thermodynamics? So if two thermodynamic systems are each in thermal equilibrium with a third body, then they are in thermal equilibrium with each other. You already heard about the mathematical equation A is equal to B, then B is equal to C. So we can call it as A is equal to C. Same fundamental you can apply in here. If body A and body C are in thermal equilibrium with body B, so A, B and C, all three body are in thermal equilibrium. So it is a very simple statement given by the zeroth law of thermodynamics. If two thermodynamic systems are each in thermal equilibrium with a third body, then they are in thermal equilibrium with each other. Here you can see the A, B and C, all three bodies are in thermal equilibrium. Now we discuss about the first law of thermodynamics. First law of thermodynamics is very well known now. There is the energy neither be created nor be destroyed. It converts one form to another form. Let's take one practical example. If I switch on the fan, then what happens? The electric energy goes to the fan and the fan will rotate and it gives the wind energy. So the electric energy gets converted into the wind energy. Let's take one more example. If I switch on the light, then what happens? The electric energy goes to the light and light will convert it into the light energy. So the electric energy goes convert into the wind energy and electrical energy goes convert into the light energy. So the first law of thermodynamics states the application of the conservation of energy, which state that the energy can neither be created nor be destroyed. It can only the change the form, like I already take the example, electrical energy convert into the wind energy and electrical energy convert into the light energy. Now we consider as a second law of thermodynamics. In second law of thermodynamics, there are two statements. First one is called the Clausius statement and second one is called the Kelvin-Planck statement. In Clausius statement, Clausius states that the heat is always flow from high temperature to low temperature naturally. If I want to flow from low temperature to high temperature, then I need to give some additional work to the system. Let's take one practical example. If I am sitting in the air conditioning room, so then I open the window and door, what happened? The cold air goes outside. No, we can call as the energy. Close the door, close the window. The cold air is goes outside. But in practical way, by the second law of thermodynamics, closest statement, energy can transfer from high temperature to low temperature. So when we open the window and door, the hot air out which is outside the room is come inside the room. So hot air is come inside the room from the window and the door side. So heat is always flow from higher temperature to lower temperature naturally. But if I want to reverse that statement, if I want to flow the heat from low temperature to high temperature, then I need to give some external work. Let's take one example as a refrigerator. In the refrigerator we can do, we can transfer heat from lower temperature to higher temperature, so that we can apply the electrical energy as an additional work. Now second statement is called the Kelvin-Planck statement. In Kelvin-Planck statement is a simple one statement. Any engine have 100 not have 100% efficiency. No one engine have 100% efficiency. That means the Carnot state that my cycle efficiency is 100%. But if we can consider the in practical way, we cannot get the 100% efficiency, so that we can call the Carnot cycle is not a practical cycle. We can call the Carnot cycle is a theoretical cycle. So in Kelvin-Planck statement, it states that Kelvin-Planck, no one has 100% efficiency. So it is a very important and very simple statement given by the Kelvin-Planck. So here in the last topic we learned the three laws of the thermodynamics. First one is the zeroth law of thermodynamics, first law of thermodynamics, and third one second law of thermodynamics. In second law of thermodynamics there are two statements. Clausius statement, heat always flow from higher temperature to lower temperature naturally, and the Kelvin-Planck statement, no one has the 100% efficiency. So this is our total last topic.